So this is one of the problems in our web assignment for lesson 2-3, where we're asked to answer a multitude of different questions related to functions and their graphs. So in this case, a graph is given of function h, and in part A, we're just merely asked to find the value of h of -2. Well, when you look at the graph, you go to where x is -2, and you see that y, or h of -2, is equal to 0. It did not go up or down from the x-axis. If we go to the graph, and so that's this point right here, if we go to the graph to find h of 0, that means we're not going to move left or right, but if we come down here to our graph of h, we see that it has a y-coordinate equal to -2. So h of 0 is equal to -2. H of 2, we go to the graph and find 2 on the x-axis and go up to the function h and determine its y-coordinate. And the y-coordinate there, where x is 2, is that y is also 2. So h of 2 is equal to 2. And then finally here in part A, we're asked to determine the value of h of 3. So we go to where x is 3 and up to our graph, and we see that the y-coordinate there on our graph is also 3. So h of 3 is equal to 3. Now, when we're identifying the domain, we're looking at how far left and right the graph of our function h goes. Well, notice this graph does not have arrows on the end, so it has a stopping point. And we can see that it's going from an x-coordinate of -3 right here to an x-coordinate of +4. And because it actually reaches -3 and +4, then that means they are included in our domain, and we would describe the domain in brackets from -3 to +4. If it did not reach those values, then we would use parentheses. For our range, it's about how high and low the graph goes. Well, I see that there is a bump up there at a y value of 3 and a valley down here at a y value of -2. And it actually reaches those values, so those endpoints are going to be included in our range. So our range goes from -2 to +3 inclusive, so we use brackets. Find the values of x such that h of x is equal to 2. Now we know the h of x is the y-coordinate. So where is the y-coordinate 2? I see this point has a y-coordinate of 2, and I also see that this point has a y-coordinate of 2. So when it asks us to enter our answers as a comma-separated list, we would just say that our x values, where h of x is 2, are -3 and +2. Finally, in this question, we're asked to determine the net change in h from an x value of -3 to an x value of +3. Well, at +3, I see, at an x value of +3, I see that our y value is 3, and at an x value of -3, I see that our y value is 2. So the net change is just 3 minus 2, which is equal to 1. Now we're also going to be asked to determine the local maximums and the local minimums. Those are the bumps and valleys as I refer to them, and I see I have one bump, and it is that one on the far right that I've already circled that has an x value of 3. So we would say that there is a local maximum at +3. There's a local minimum at the x value where we see that low point or that valley. And obviously that low point here is 2. So when it asks for the local minimum, we'd say the local minimum is the actual y value, but it does occur at an x value of 0. But we report the minimum height or minimum y coordinate there. So that's -2. I think I said 2 a moment ago. And then our local maximum reaches a maximum height of 3. But to be honest with you, there's another local maximum, and it's that bump where it stops at x of -3. So that is also a height of, or that is a height of 2. So another local maximum would be at a height of 2. Now, granted, it does occur when x is -3. But when they ask for the local max and the local min, they're wanting the y coordinates. And then there's also another local min over here at the other end of our graph. It occurs where x is 4, and it is the low point at a y coordinate of +2. So there's another local minimum in this case at +2.